Hello and welcome to Kumat Online Academy. Today we want to continue with our discussion on density, and we are going to talk about how to determine the density of liquids. We're actually going to look at the determination of density of liquid and powder. So we are talking about liquid and powdered substance. Powdered substance. Okay, so we are looking at this uh, determination of density of liquid and powdered substance. In the previous lesson, we talked about how to determine the density of solids, how to determine the density of regular solid and that of irregular solid. But today we are focusing our attention on liquid and powdered substance. So how do we do this? If we are given a certain liquid to get its density, how do we do it? To get the density of a liquid, the first thing to do is to get what we call density bottle. We can actually use any bottle to do it, but we prefer using what we call density bottle. You get a density bottle, you weigh the empty density bottle using your weighing balance. Then you record the mass as M1. So the first thing to do, weigh an empty density bottle, an empty density bottle. Now record the mass as M1. Record the mass as M1. Then the second thing to do is to get the liquid you want to get its density. Determine the volume of the liquid that you want to use. So you're actually going to get a measuring cylinder. Fill the liquid to a certain volume. 2. Get the volume of the liquid using a measuring cylinder. You know your measuring cylinder is a very common lab equipment. So when you measure the volume of liquid you want to use, then use it to fill the empty density bottle. 3. Fill the empty density bottle. With the liquid. Fill the empty density bottle with the liquid. And when you fill it with the liquid, of course, the mass of the density bottle will change. Its weight will change. So you measure the mass again and get the mass as, record the mass as M2. That is the new mass. This M2 is the mass of the density bottle and the mass of the liquid you have filled or you have used to fill it. Now, assuming that the volume of the liquid you used is V, assuming that the volume of the liquid you used here, the volume of the liquid is, let's say that the volume is V. Now we can get the density of this liquid by saying that density is equal to mass over volume. Now, how do we get the mass of the liquid? That is just the major thing in this experiment. Getting the mass of the liquid. The mass of the liquid is equal to the mass of the liquid and the density bottle minus the mass of the empty density bottle. So we minus the mass of the empty density bottle from the mass of the density bottle and the liquid to get the mass of the liquid alone. So our density D now is equal to mass of the liquid plus the empty bottle, which is M2, minus mass of the empty density bottle alone. Now that is M2 minus M1, this over the volume we have, which is V. So when we do this, we'll be able to calculate or determine the density of the liquid. So this is very straightforward, very simple. Now let's look at some examples. Or let me treat that of liquid the same way we do for liquid. It's the same way we determine the density of powder, because a powder is not that rigid that like solid, which you can get its mass directly. So what we do to get the mass of a powdered substance is to also put it inside the density bottle and then get the mass just the way we did for the liquid. So if you are asked to show the method for determining the density of a powdered substance, you just give the same method for this liquid, only that you have to change the liquid to powder given to you, or just say that instead of saying you put or measure your liquid, now say that your powdered substance is measured into the measuring cylinder to get the volume, and then you are subtracting the mass of the empty density bottle from the mass of the powdered substance and the mass of the density bottle. So it's basically the same thing that you are going to do. So let's now go to the examples. Example 1. Example 1. We may be asked to get an empty density bottle weighs 2 kilogram, when filled with 0.5 meter cube of certain liquid, it weighs 5 kg. Determine the density of the liquid. Solution. Now solution. How to solve this? We get the mass of the liquid alone from the mass of the liquid and the density bottle. That is the major thing we try to do in this kind of case. The mass of the liquid and the density bottle is 5 kg. That is our M2. M2 is equal to 5 kg, and M1 is the mass of the empty density bottle, which is M1 is 2 kg. Now the volume of liquid used is 0.5 meter cube. So our density now is equal to 5 minus, or let's say M2 minus M1, M2 minus M1 over V, and that gives us that D is equal to 5 minus 2 over 0.5, that is 3 over 0.5, that gives us 6 kilogram per meter cube. 6 kilogram per meter cube. So that is how to solve this example. Now the next question number 2, example 2. A liquid of density 1.2 kg per meter cube was used to fill an empty density bottle. If the weight of the density bottle doubles as a result of the liquid, find the volume of liquid in the liquid in the bottle. Find the volume of the liquid used if the empty density bottle weighs 2 kilogram. Okay, so here we are told that an empty bottle, when we fill it with a liquid of an unknown density, the weight of the empty bottle doubles. That means that if the density of the empty bottle is 1, when you fill it with the liquid, it becomes times 2, that is 2. If it is 2, it becomes times 2, that is 4. Now we are told that the empty density bottle weighs 2 kilogram, that is M1. If if the empty density bottle weighs 2 kilogram, so the weight of the empty density bottle is 2 kilogram. Now, and we are told that M2, which is the mass of the liquid and the mass of the empty density bottle, is 2 times the mass of the empty density bottle alone. So M2 is equal to 2 times M1, which is equal to 2 times 2, equal to 4. So our M1 is 2 and our M2 is 4. Now, the volume given to us, we are given the density. We are given the density as 1.2, and we are looking for the volume. Okay, so volume density is equal to 1.2 and volume is unknown. So our density is equal to M2 minus M1 over V. That means that 1.2 is equal to M2 is 4 minus M1 is 2 over V. Now that gives us that 1.2V is equal to 4 minus 2 is 2, is equal to 2. So V is equal to 2 over 1.2, which is equal to 3, which is equal to 3 points, which is equal to 3.3. 3.3. So this is the answer. Example 3. Example 3. The ratio of an empty density bottle, the ratio of the mass of an empty density bottle of the mass, the ratio of the mass, the ratio of the mass of an empty density bottle to the mass of the bottle when filled with a liquid of an unknown density is 3:8. If the volume of the liquid If the volume of the liquid used is 4 meter cube, calculate the density of the liquid. Calculate the density of the liquid. Now solution. We are given that the ratio of mass of the empty density bottle and mass of the density bottle when filled with liquid of an unknown density is 3:8. Now what this means is that when the bottle is empty, if it weighs 3 kilogram, it will weigh 8 kilogram when filled with the liquid. So M1 now is equal to 3 and M2 is equal to 8. That is what this ratio gives us. It shows the mass of the empty density bottle and the mass of the density bottle when filled with the liquid. So now we have our M1 and we have our M2, and we are told that the V is equal to 4 meter cube. We are asked to calculate the density of these liquids. Density D is equal to M2 minus M1 over V. So density is equal to M2 is 8 minus 3 over 4, which is equal to 5 over 4. Therefore, our D is equal to 1.25 kilogram per meter cube. This is the answer. So in this lesson, we've seen how to determine the density of a liquid and the density of a powdered substance. And the basic thing we do here is to determine the mass of the liquid or the powdered substance from the mass of the liquid or powder substance and a density bottle. Once we get this, we use it and then get the volume of the liquid or the powder substance to get the density of the liquid or the substance we are looking for. So I hope that the lesson is very clear. Thank you.